Hey friends, we are still in chapter 8 and we're looking at a section 8.7, which is slope-intercept form of a line. So let's get started. We have one vocabulary term or one vocabulary phrase, which is slope-intercept form. And it's an equation of the form y equals mx plus b, where m is the slope and b is the y-intercept. So for example, if you had an equation that was like this, y is equal to 2/3 x plus 5, by just having it in this form, notice it meets the requirement of being in the y equals mx plus b form, which is a slope-intercept form of a line. You know automatically what the slope is, and you know what the y-intercept is. So this gives you power to graph this really quickly. You know that the y-intercept, the place where the graph hits the y-axis, is going to be at 5. So you would go 1, 2, 3, 4, 5, and right there is where you'd know that the graph is hitting the y-axis. So that's a point on the line. And then you can rock out with your slope knowledge to say you're going to rise 2 up 2 over 3, 1, 2, 3, rise 2 up 2 over 3. And if you can connect those dots like that, you would know that you had the actual graph of the line. So slope-intercept form is really important, powerful, and extremely useful. And we're going to see that in a couple of examples. So here's example 1. We're going to find the slope and y-intercept given a particular equation. We remember that the slope-intercept form is y equals mx plus b. So if we can get the equation in this form, we've got a lot of information. And fortunately, this is quite an easy problem because they gave us the equation in this very form, pretty much, right? So what I'm looking at here is I see that 1/4 is in the place of the slope. So I can already say that the slope is equal to 1 over 4. The y-intercept is not 6, but -6, because remember, we're going to look for whatever, in a sense, we're adding to this part of this x term, right? So what am I adding? I'm technically adding a plus a -6, so I'm going to look at this as -6. So my b term, let's do that in a different color. My b term, or my y-intercepts term, is -6. Pretty simple, right? So you can see that this is a really powerful form of the equation. Let's go ahead and look at, of the linear equation. Let's go ahead and look at another example. State the slope and y-intercept of the graph of this particular equation. Now, we remember that the form we're looking for is slope-intercept form of a line, y equals mx plus b. This is not in y equals mx plus b form, but we have the power to move things and manipulate equations algebraically so that it remains equal, but it's in a form that's more appealing to us. So what we're going to do with this equation is we're going to do exactly what you think. We're going to move some things around. Let's start off with the original equation here. And I need to get y by itself, preferably on the left side. So I'm going to get rid of this x term by adding the opposite, or its additive inverse, to both sides. When I do that, y is equal to a positive 4x plus 2. Notice I put the 4x here because I wanted it to mirror this form. So I put the 4x first and then the 2 afterward. Is it wrong to put it the other way? No, it's not wrong. It's just not in the proper form. So now that it's in the proper form, y equals mx plus b, I can clearly see that my slope is 4 and my y-intercept b is 2. So this would give me a lot of valuable information when graphing this equation. Example 3 is actually to graph an equation. So here we have an opportunity to graph y equals -2/3 x plus 3 using slope-intercept. So I can quickly look over here and see that the the slope is going to be over here. I'm trying to highlight it in yellow. The slope is this -2 over 3, and the y-intercept is this 3 over here. All right, so that's all I need to graph. So let me get started graphing. So here is my x and y axes, and I'm going to start plotting some points. But first, what I want to do is find my y-intercept, which we know to be 3. So I'm going to go straight up on my y-axis to the number 3, because remember, the definition of y-intercept is where the graph actually hits the y-axis. So let me change the color there. So my y-intercept is right there at 3, and my slope is -2 over 3. Let me write that out. So m is equal to negative 2 over 3. Now, this can be written as negative 2 over 3, like that, or I can write it as 2 over negative 3, because I know when I divide a negative by a positive, I get a negative. When I divide a positive by a negative, I get a positive. The reason why I'm writing it in different ways is because it can help me, it can be really instrumental in helping me figure out where other points are. So for example, if I'm thinking about it this way, right, I can look at it and say, well, I'm going down 2, 1, 2, and then to the right, 3, or positive 3, 1, 2, and 3. And that will give me a point here. If I'm looking at it in this way, and let me use a different color just to illustrate, if I'm looking at it as a positive 2 over negative 3, then I think about going up to 1, 2, but going in the negative direction 3, 1, 2, and 3. Notice that these points are collinear. They're going to fall in the same line. What it means is it doesn't matter which way you look at it, as long as you're being honest about the fact that you have a negative or a positive slope and assigning that negativity to the top or bottom. Doesn't matter, but you will still get points on that line. So we've got the points that we want. It is really hard for me to graph, so please bear with me when I try to graph these lines. But we get a line like that, and it seems to feel comfortable with the fact that we've got a negative slope. We know negative slopes go up to the left, and we have a positive y-intercept, which is going to give me that positive 3, and I'm feeling good about myself. Let's see if we've got another example that'll be helpful. Okay, so here we have an example about analyzing the slope and y-intercept. So here we have a typical leopard gecko is 3 inches long at birth, and you can see the little guy right here. He's so really cute. All right, they grow at a rate of one-third of an inch per week for the first few months. The total length of a leopard gecko, y, after x weeks, can be represented by this equation. So let's take a look at this for a moment. So what this equation is giving us here is telling us the height after X number of weeks have transpired of a baby gecko. So you realize that on the 0th week, when the baby gecko is born, it's already 3 inches. And then it's going to add 1/3 of an inch for every week of life, right? So this equation really represents the situation. So what are we going to do with it? Well, what we're first going to do is we're going to graph the equation and then kind of just figure out what everything means. So I'm going to start off by not really going to do an XY axis with the negative portion, and the reason why is just because I don't need like what's going on negative like before on negative weeks, right? I just need to start at week 0, and I know I'm going to have all the growth that I'm going to be talking about is positive, so I'm only looking at the first quadrant. So X, this is the number of weeks, and this right here would be the Y would refer to the length. Okay, so that's length in inches of the gecko. So now what we're going to do is we're going to do exactly as we've done before. I'm going to just put some evenly spaced lines on each of my axes. Probably should have paused this and done that, but that's all right. And I'm going to identify my y-intercept, and that's at 3. And my slope is going to be rise over run, go up 1 over 3, up 1 over 3. And I get a line that looks something like this, and something like that's going on. And so what this gives me the opportunity to do, it gives me the opportunity to graph, make a visual representation of what we discussed in this problem, but it also gives me an opportunity to predict what could happen. So for example, if I were to say, well, what happens in the 8th week? How long is a leopard gecko in the 8th week? I can visually see that, or I can use the equation, put 8 in for 8th week and calculate the value. So that's basically what we do when we analyze it and we graph things and we can look at information that we're given. All right, I hope that made sense. I look forward to talking to you guys very soon about this lesson or any other questions you have. I'll talk to you later. Thank you. Bye-bye.